Another tool that we can use for active reconnaissance is known as Netcat. Now, Netcat is actually known as the hacker's Swiss Army knife. That's how useful it is. So it's pretty essential for establishing remote connections to devices that we're going to exploit, when you're actually conducting ethical, hacking activities. And you can also use it as a port scanner in some scenarios. So Netcat has the ability to allow you to either, scan for like maybe open ports, but primarily it can be used to listen to connections as they come into your system or to other systems. So let's go over like some quick, netcat syntax and examples. So if you want to run the netcat command, so all you have to do is type in nc right here, and that's going to call the program. And then this dash nvv is just saying, hey, run this port scan in very verbose mode, just like with mmap. It has the same type of verbose option. If you don't want to see the verbose output, then just take that off. Then we have dash w, and that means, hey, don't time out until like a second pass, and then you can move on. So you can just do that to set how long it'll pretty much like limit how long it'll actually take, because sometimes these scans can take a while. Then you can do a dash z to actually say, hey, no data transfer mode. So that's actually going to make it run a lot faster. And then we can have our target address right here, which is the metasploitable machine for us right now. And then let's say we have ports 1 through 100. So we can go ahead and do that and hit enter, and it's going to spit out our results very, very fast. If you run this without the dash Z, it will be very slow. But as you can see, it tells us, hey, connection refused, connection refused. Hey, port 80 is open, connection refused, connection refused. And you can see what ports are open. This aligns perfectly with our mmap scans before. So you can use this as a viable, port scanning tool as well. So you see port 53 is open. Let's see if anything else open right now. SSH, FTP, Telnet, SMTP. This is stuff that we're going to look at later, but this is just showing you, how you can actually use Netcat as a port scanner. And just to note as well, if you wanted to, you can use that as a UDP scanner as well. You would just have to add a dash U option like right here, and it'll actually scan the UDP ports. So it might be a little bit slower when you're doing that. As you can see, it's kind of like just trickling through, but it'll eventually get through the entire list, and then we're pretty much good to go. And you'll probably see, I think only like for 53 was open. I don't remember exactly for the UDP one. As you can see, you can use this for UDP scans as well. So it's a very versatile tool. Okay, so another way that Netcat is very, very useful is that it allows us to actually listen on ports, either on remote computers or locally, for any traffic that comes over that port to that computer or to our local computer. So what we're going to do right now is just a very quick example of actually using Netcat to listen on a port. So all you have to do is call NCAT again with NC, and then you put dash NLVP. Now the L is going to put us in listening mode, the V is going to give us verbose output, and the P is going to allow us to specify a port. So we could put a target address here if we wanted to connect out to another port and listen, over that port for traffic. But right now we're just going to do this locally. So we're going to listen, hey, if anyone connects to us over port 80, let me know what happens. That's pretty much what this is saying. Now we're listening on port 80. We know that our IP address here ends in .107. So let's actually go over to my Windows machine that I'm doing all this on, and let's see what happens when we actually type in HTTP and then the IP address of my Kali Linux machine. So as you can see, it's spinning. I don't have a web server or anything hosted right now, like that's pushing out stuff. So it's just gonna spin and it's not gonna do anything. But if we go back to our Kali Linux machine and we click back over here, oh hey, it says, hey, we got a connection request from 192.168.56.1. And it's giving us like just different information. This is just the HTTP header, and it's just telling us this is very useful for catching connections and maybe also like viewing things like potentially in plain text that's sent over it. There's a lot of versatility that comes with this. So that's an example of how you can use NCAT to listen for connections and different traffic and such. Just quickly to show you guys, so I went back and actually to show you that things that are passed into the URL can actually be seen over on a Kali Linux machine. So this is just an example, and maybe it's an insecure application and it passes stuff over plain text like in the URL. So user and then a variable password or pass that equals pass. To our Kali Linux machine, it'll actually show us it right here. So it's pretty useful for catching information. So just keep that in mind. So one other thing that you want to do when you're conducting your active reconnaissance is looking for SMB enumeration. This is server message block, and it's very key, like when it comes to like corporate environments, to look for SMB vulnerabilities. They're very common and they're not too difficult to exploit as well. So if you don't know, server message block, or SMB, is used for file transfer, and it's found on ports 139 and 445. And like I said, easy to exploit most of the time. On some devices, if you can exploit it, you can actually own the entire system. Like, you have access to all kinds of stuff and be able to get like a root account like almost immediately. And SMB enumeration can be done with a variety of tools, but we're gonna focus like right now on using Nmap. But there's other tools as well. Okay, so we're back on a Kali Linux machine. So let's say we want to find out about some SMB. All right, what we can just do our simple nmap command. And then for this, we're going to ask for verbose output because we want to see stuff as it's happening. It's pretty cool. We're going to do a -p to actually specify the port. And then we're going to say 139 and 445 because we know that, those are the ports that SMB runs over. And let's say that we want to, output the file to like smb.txt. And then we want to put the target. So 192.168.56.104. This is the metasploitable machine. We're going to go ahead and actually run this command. And then now, okay, hey, it found that those ports are actually open. So one other neat thing that we can do with Nmap is that we can actually specify ranges. So let's say we wanted to do 1 to 2, 5, 4, just for example. It'll scan everything on this subnet pretty much. So, and look for those ports that are being open and put it into this file. So let's go ahead and run that. You might need to give it a little bit of time, but it's going to give us a full report, for each system, each address that it found, and actually tell us, hey, they're closed on this 107 device. I believe that's my Kali Linux machine. Let's see, there it's filtered on here. It's open on 104, as we know. It's filtered there. It's open over here on the 20, which is actually the domain domain controller, and it's also open. Let's see, okay, and it's open locally because I'm allowed that to happen. So that's a good way to figure out, if SMB is something that you'll be able to exploit. So you can actually take this a step further and actually run like a SMB like vulnerability script. So we could just do ls /usr/share/mmap and then /scripts/smb -vul, and you can just put a star, and it's going to give us all of the different like SMB vulnerability scripts. So these scripts actually go through and check if a specific system is vulnerable to these specific vulnerabilities, and you can just call it with the -- script command. So let's just test it out. I'm not sure if it's actually gonna work, if it'll actually be vulnerable, but let's try this on the Windows server that we have. So let's see, let's do an nmap. Let's see, -v for verbose. Let's do a -- script equals, and then let's actually just paste one of these because these are like the Microsoft Windows ones, because you never know, it could work. -- script, and then we could just copy this over. We can just copy this down there. So paste selection, and then it's actually gonna run that script. Didn't put the IP address, 192.168.56.20. Let's see what happens. So it's actually gonna go ahead and run an nmap scan. It's gonna go through and actually run this script for us as well. Okay, so our script ended up finishing. It ran the vulnerability script on it after it did an nmap scan, and it's saying, hey, it's potentially vulnerable to remote code execution because of SMB version 1 being used. So it's pretty big. So if you find something like this in your network, you'll be able to exploit this pretty easily, and we'll get into this later and actually clarify if this is real or not. As you can see, you can test out these other scripts as well, but as you can see, nmap is very versatile, and it'll allow you to find vulnerabilities like this right here, like this SMB vulnerability. Another type of enumeration that we want to do during our active reconnaissance is actually NFS enumeration. NFS stands for network file share. It's another thing that's key, when we're doing this active reconnaissance. So NFS runs over port 111 and is typically used to mount network shares that can potentially be exploited, if it's set up incorrectly. So we can actually enumerate NFS information using Nmap. So I'm going to go ahead and show you how to do that. We're backing our Kali Linux machine, so we have our Nmap command set up. So right now it's set to where it's going to do a service scan and figure out the version of it with this -SV right here, and then we have -P, and we're looking at port 111. So we're trying to see, are there any devices that have port 111 open, and then I put it in very verbose mode so it actually shows us what's happening while it's happening, because it's pretty cool. Then we have our target right here, and if we want to do the NFS enumeration, we can actually just do -- script and then equals, and then what we're gonna do is RPC info. Okay, so we can just go ahead and run that, and then let's wait a minute and check out the results. So we're going to go ahead and run this command right here. So it's just a simple nmap command. It's going to do a service version scan. It's going to scan port 111, and we're putting in very verbose mode. This is going to be our target. As you'll see, this is our Kali Linux machine. So what I did was I went ahead and set up an NFS server locally on this just to show you how this works, and I'll include some instructions for you guys to actually go ahead and set up an NFS server locally as well, so that you can actually practice it and try it out on your own. You'll probably find that in the resource section. So the script that we're going to use right now is RPC info. So pretty much what this is going to do is it's going to allow us to see which devices are actually registered with RPC bind, and that's going to tell us if it points to NFS or not. So we can go ahead and run this one and just give it a second to finish. So I scanned finish, and hey, it said port 111 is open. RPC bind is running on it. And hey, we found this NFS share right here /MNT/hacking share. And it has these files inside of it. You can ignore those first two. But what's interesting here is the super secret password.txt. So that's pretty neat. We know that's probably a file that we want to know, what's inside of it. Let's look a little bit more at some of the information it actually gave us. So we see that mount is actually accessible to anyone that's on this subnet, and hey, we broke into the network technically, so we're on the same network, so we should be able to gain access to it. So we don't have any restrictions there, and it just gives you a little bit more information, about the NFS share as well. So we can take this a step further and actually try to see if we can mount it to our system to where we can access it. And we do that with a mount command. So I've already done this, but I'm going to show you guys the mount. So it's just mount followed by the IP address of where the NFS share is, and colon, and then the NFS share, and then our own folder. So I made a folder called my NFS in the /mount folder. So what we can do is we can cd/mnt/my NFS, and we can do an ls, and hey, it actually synchronized, it actually went and mounted that NFS share locally here. Now I can access this file right here. So if I wanted to, I can do a v super secret password.txt, and hey, I have read access to it. That's pretty crazy. I can also, if I wanted to, I could just do cat super secret password, and it'll cat it out. So now I have a super secret password. So that's pretty neat. So now you see kind of how NFS enumeration can be very valuable. You can find some messed up permissions usually on most internal networks if you look for this.